Welcome back to another episode of the DNA of Things. I'm your host, Dr. Jeremy Koenig. Today's guest is Mary Olson, a dedicated advocate and researcher focused on the disproportionate impact of ionizing radiation on women and children. With a background in biology and biochemistry, Mary brings a wealth of knowledge and passion for improving public health through her work on radiation safety and policy. Now, in this episode, we'll explore Mary's journey into researching the impacts of ionizing radiation, starting with her own personal exposure. We discuss her groundbreaking findings on the disproportionate effects of ionizing radiation on women and children, and how these insights have shaped global policies, including the Treaty on the Prohibition of Nuclear Weapons. Finally, we look at the future of radiation research and the critical roles of genetics. Listeners will gain a deep understanding of the intersection of radiation and DNA, the importance of informed advocacy, and the potential for significant change in public health policies. It is my absolute pleasure to have Mary Olson with us today, whose extensive research and advocacy work on the disproportionate impact of radiation on women, of course, is grounded in her background in biology and biochemistry. And so today, I anticipate this conversation will certainly center around some of the advocacy work that you're doing. But if experience has taught me anything, I suspect we'll be getting very deep and philosophical on all things biology, but even potentially culturally and spiritually. And so I'm excited to have this space to explore the depths of your knowledge and contribution. So welcome, Mary.
Thank you so much for inviting me, Jeremy, and it's a lovely thing to talk with you. I'm glad we're doing it today. I want to start with just one bold statement about the relationship of your broad field being genetics and my broad field being radiation, because the first and foremost impact of radiation on a human body, unless it's so high to cook it, right? That barely ever happens, but it certainly does if you set off nuclear bombs. The primary impact of radiation is on DNA. Any kind of radiation can break a DNA strand. So if there's replication going on and the strands are exposed, that's a more vulnerable time, which is why children are more impacted because their cells are dividing more regularly. But the internal emission of radioactive decay particles, the alpha and beta, can break whole chromosomes. It can break mitochondria, little organelles of the cells. And so what you talk about and what I talk about are intimately connected. And the younger generation has actually often never heard that radiation causes cancer. They hear of radiation as a treatment for cancer, but they haven't always heard that this type of damage to DNA doesn't always, but can result in the primary outcomes being cancer, infertility, birth defects. Mm-hmm. And it's the cancer discussion where we see female bodies disproportionately impacted. We're going to unfold that. But I need to say that the whole big finding is that biological sex is a factor in radiation outcome, because we also now know that cardiovascular harm results from ongoing radiation exposure, and that male bodies are more subject to that, and that stroke and heart attacks are now known to be outcomes for people who are chronically exposed to ionizing radiation. Females get these problems, cardiovascular problems, but at a much lower rate than males. And of course, males get cancer from ionizing radiation, but at a lower rate than females. So the big, huge topic here of radiation's impact is so tied up with your field that it's like, duh, why haven't we all been talking to each other a whole lot more often than I think happens? So this is great. This is a wonderful conversation.
Well, thank you for that preface. And, we do certainly have some conversation items to dive through, but, just again, hearing you speak, I think about some of the things that I was taught, even in, university and advanced degrees, keeping in mind that my graduate studies work was very, let's say, ecologically based. So that is like molecular ecology. So looking at the nature and distribution of genetic elements, in most instances, mobile genetic elements. So that's the DNA that moves within and between different bacterial species and manifesting in all kinds of things, like, say, pathogenic organisms, superbugs. But also, like, the interesting thing was just my fascination with the underlying evolutionary process. And then, of course, we talked about this notion of Russian dolls at the beginning of the call, like the idea that bacteria are in us, more bacteria in us and on us than there are human cells, and those genes are interfacing with other genes. So I give that context because I've always looking at things as ecosystems that drive evolutionary processes. And then, of course, there's the context of the environment. So for you to start with, hey, ionizing radiation as an environmental stressor is really interesting, because the point I was trying to make was that, right, this notion of, well, why do we see more cancer? And the argument that I bought was, well, humans did not evolve to live past 19, let's just say 10,000 years ago, 30, maybe 40 if you got super lucky. So, we had all these hitchhiking genes that, kind of avail themselves later in life. So basically their negative effects, tend to show themselves later. But of course, we know that the replication process during cell division is not perfect. And so, there are certainly mutations that will happen in a lifetime. So for me, it's kind of like, now I think about the accessibility of different kinds of technologies that weren't available when I was doing research, say 20 years ago, which, like, single cell DNA sequencing. We can sort of get to the molecular ecology of individual human cells now, which is just amazing. And so it is getting to, the nature of how various, cancers, which is very simply put, uncontrollable or runaway cell growth, but the causes of which, we've learned things like, there are various chemical compounds that may be mutagens or volatile or organic compounds. But yes, this whole notion of radiation is not something that I'm expert on. And so I love having experts on the show who can enrich my perspective and the perspective of our listeners. So what a great intro. And, maybe just to set the stage, and let's add some, temporal context, chronological context, if you will. I'm really interested in, obviously the topic of how ionizing radiation and its impact on biological sex, the number of projects that you have on the go. So interested in the things, but also very interested in the person. So how did you get to where you are? And, like, say specifically, let's start with, could you share your journey into researching the biological sex specific impacts on radiation? And so what inspired this area of focus? I know we've talked about it before, but I think it's a compelling story. And I love for our listeners to hear it.
Absolutely. And I'm actually going to go a little bit deeper, a little bit further back than you and I have spoken about, because I'm second generation. My father was an evolutionary biologist, and he was at the front of the line as the nuclear age appeared and began unfolding. He was a graduate student in California. He was at Caltech when Oppenheimer was there. He was at Scripps Institute, and his work was on the evolution of microorganisms in the water. It had absolutely nothing to do with radiation or fission or nuclear weapons at all, but he was a scholarship student. We'll keep this short, but just the punchline of the story is that he had to work for his major professor in the afternoon on the major professor's work, which was analyzing water that came back from the Bikini Atoll tests of nuclear weapons in the Pacific. So I grew up in a family where my father had absolutely no doubt that the fission and its fission products were damaging to life of every kind. And he raised me with that perspective and that understanding. Now, my mother happened to be pro atoms for peace. And so that put a real spin on things, shall we say. And there was dynamic energy in the household about all this. But I, as a child, understood a whole lot of what I carry forward now, because both my parents were scientists and I was immersed in an environment where information was at a very high level. And so in 1984, I ended up after college taking a job in a research institution where I was being hired to be an assistant in research. I was not a student, I was a worker, and told that I would be working with radionuclides. And I almost didn't take the job, which would have been better for me because 2 weeks in, I got contaminated with a radio tracer. And the lab had much, much higher levels than most typical research labs would keep on stock. So, I had some symptoms and some consequences that happily have not been anything that killed me. But I became native to the whole matter of physically being exposed to radiation at a young age when I was childbearing, and not in an organized medical situation where you have some amount of disclosure and consent. And although, I think they could do better there too. So, long story short, I went to recover from my radiation incident in a different environment outside of research. Thought I was done with biology, done with radiation, until I got a message in the mail saying that, still don't know who put me on that mailing list, but saying that an organization was organizing to oppose the deregulation of about 1/3 of the so-called low-level waste in the United States, that the regulators simply wanted to declare it not radioactive. So this would not be labeled in any way. There would be no warning or disclosure. It could be recycled into consumer products. And it allowed a lot of averaging of who was exposed to how much over what time period. I started understanding the ways in which there are enormous loopholes in the regulation and quote unquote safety protection standards in the United States and worldwide for people in the general public who are being exposed to the products of both government and private industry. So I couldn't stay home, is what you say. And I think one of the themes we're going to bring into this conversation is the notion of service. On the one hand, I was angry that what had happened to me had happened. There wasn't better protection. There wasn't better follow-up with me as somebody who'd experienced radiation accidentally at a pretty acute way. But more than that, I felt an ethical obligation to prevent this same thing from happening to other people. And so my stepping up 5 years after I'd cooled down from being quite so angry was still fueled by that emotion, but was very considered as service and as ethical action towards preventing something bad that would impact a lot of people. I ended up being hired by the very organization that had sent that notice in the mail. It was about a year later. And we ended up getting Congress to revoke the policy of the U.S. Nuclear Regulatory Commission in a big, huge piece of legislation under the first Bush presidency, the father, Bush Sr., in 1992. And that's what brought me into the field. So there I am working on radioactive waste policy for the next close to 20 years when a woman asked me in an educational talk setting, she raised her hand and asked whether radiation was more harmful to her as a woman compared to a man. And this was about 2009 now. And I had never heard that question. There was some data released in 2006 that formed a basis for that question to come forward. The National Academy of Sciences put out a huge report called The Biological Effects of Ionizing Radiation that was the 60-year summation of tracking the people who survived the United States' first nuclear strike on cities full of people in Japan in August 1945. And that data set is, on the one hand, part of a crime against humanity, and on the other hand, our only large group of 100,000 people that includes male, female, and age from infancy to age 80 who were exposed on the same day to this prompt radiation. So we can go into more about what that means, but in any case, it is a data set. And that is what there was a big report from which my work is an independent analysis. So I had no answer that day in 2009. I hadn't done that work yet. And that question is why I ended up doing the work, but not right away. This was so profoundly disturbing to me that I hadn't even thought of the question, that none of my colleagues had brought forward this question of male versus female, that I actually forgot it. It became sealed in my mind. And it wasn't until I saw the video from Japan, sort of cosmic, horrific joke that they have Hiroshima and Nagasaki cities destroyed by nuclear weapons. And now they have the largest meltdown in the nuclear reactor world on record, which is the Fukushima Daiichi situation that occurred after the tsunami hit and they lost all cooling and all electric power. 3 reactors melted down. And on seeing these reactors literally exploding, because they did, hydrogen explosions took out the containment on units 1, 2, and 3, and there was potentially another smaller explosion in unit 4 in the fuel pool. In any case, you see that. You're standing there, you're in your office, you see these reactors exploding on video, and the question flooded back. I had absolute obligation to find an answer. And there was one paper buried on a website by a colleague of mine, but I had missed the memo in 2006. It was a story about disproportionate impact on children, which I kind of thought was old news at the time, and I didn't read it. It turns out it was on male versus female and age of exposure. So that work was done, but I didn't know it, so I repeated it. And in science, we like replication. We like confirmation of results. And indeed, this was all data collected by scientists and published by the National Academy of Science. So, all I basically did was become a communicator of these findings. And they are enormous findings, in my view. And in fact, they have helped to reshape aspects of our nuclear world. So that's how I got here. I had a daddy who raised me right, had a bad accident that could have ended many things in my life, but instead became the beginning of many things in my life. And I came from a point of view of service, and that helped me to stay on track and be ready to be the catcher when the ball was flying my direction.
Wow.
And, you just have to trust it some days. You just have to trust it.
Wow. What a beginning. So you take on this question, the difference in the effects. What are those differences in the effects?
So we have a mirror from the survivors, and it's a statement of what happened. The question of why it happened has yet not been fully addressed, but we do have a hypothesis we can discuss, and I have recently done a review of literature that we can hold up against that hypothesis. So what happened is the first question you're posing. So these nuclear weapons vaporized concrete, steel, and of course, people. And the mushroom cloud that you see is actually not the bomb. It is what was vaporized in being lifted up by the incredible heat of the explosion, which is why you make a bomb, so you can burn everything up. That is the weaponization of fission, is that heat. So the people who were sufficiently sheltered to be able to survive, as I said, they were people from age basically 0, birth, infants, all the way up to age 80, who were alive 5 years later when scientists came to start studying them. And again, I have to emphasize, there are principles now. And in war, conducting a scientific study without the consent and voluntary participation of people is absolutely unethical. And if I could have stood back, I would have stood back, because it tarnished my soul. I know this, to participate in the data that came from those events. So before I say anything more, I'll simply say there is no other big data set where you can do statistical level analyses to make findings that includes females and children because the worker studies, which is the other major source of information about radiation, is the atomic workers who built all the nuclear weapons during the Cold War, and the atomic veterans who were marched into battlefields to some degree were also studied. Those individuals are adults and primarily male, almost exclusively male in the studies. So it's a study of a section of the human life cycle, lifespan, not the whole thing. And the findings I'm about to tell you depend greatly on being able to see what happened to people of all ages, because it turns out that everybody who was exposed had the possibility of getting cancer. There was an increase in cancer over the control population, not hugely, but the distribution of different cancers is a question that I'm beginning to unfold. And it is somewhat different than the control population that was also set up 5 years after the bombs. But the total cancer incidence is where my finding really rests. So if you're counting cancers like a bean counter and you do it over 60 years, the finding that comes forward is that the people who got the most cancer in the following 60 years were the youngest children who were exposed. And this is adjusted for per capita and demographic factors. So it's not that they lived longer, it's they were more sensitive.
What do you mean by more cancers? Do you mean multiple cancers, or cancer was overrepresented in the younger population, or both?
Cancer occurred to the largest amount in the youngest group of age cohorts. The survivors were studied in age cohorts of 5 years, and the data was disaggregated for male versus female. The sex was assigned by the researchers, as far as we know, purely binary. So the people who survived the bombing, who were between birth and 5 years old, as a group, got the most cancer. Inside that group, for every male who got cancer, and males got cancer, 2 females got cancer. So it's a doubling in that youngest age group, which in biological research at the level that I work with, I'm not talking about cells like Jeremy talks about, I'm talking about whole organisms. That's a stop the music moment if you have a doubling outcome.
Right.
So it tapers off. I actually have a couple pictures I can share. Should I share them?
Do you know what we can do is I can interlace them afterwards.
Okay.
So yeah, if you want to send me those afterwards, I'll definitely put those up.
Sure, no problem. So basically the picture is this. If you look across all the age cohorts and look at male versus female for total cancer incidence, in every single age group, females got more cancer. But the difference is greatest in the young children. So it is that exposure is least likely to be tied to occupational differences, to, there's some amount of body type variation, body size, etc. But those youngest people are generally closest in size. I would think that they're not doing lifestyle things like alcohol and cigarettes. It's sort of pointing towards physiological factors. And so I said we had a hypothesis. It was my mentor, Dr. Rosalie Bertell, one of the recipients of the Right Livelihood Award, sort of the alternative Nobel Peace Prize. And Rosalie said, through her many years of working on radiation impacted populations, that she thought it had to do with reproductive tissue. Both male and female bodies have reproductive tissue, but female bodies have a higher concentration.
Right.
And so that was her hypothesis. And I've recently been retained by a UN agency. We're not to press yet, so I'm not going to say which one, but to review literature and see if there is an update on the findings that I put in my paper. My first paper was called Atomic Radiation is More Harmful to Women, because one of the key things I haven't said yet is that this exposure to the youngest children did not necessarily result in an increase in childhood cancer. It resulted in an increase in cancer over their lifetimes. So if you can imagine an adult population. In that adult population, there are some that were exposed as adults, but today there's some who were also exposed as children, and they have a different risk factor for cancer, even though they're now all adults. So I think one of the biggest outcomes of my work ends up being that radiation is not uniform. It matters what your biological sex is. It matters what the age is when you receive the exposure. And then all the other things, okay? I'm not saying those are the only things that matter. I'm simply saying that you can no longer treat radiation as indiscriminate, which is how I was introduced to it. My education was based on the idea that there were doses that were consistent, and you could basically slice and dice and manipulate information about populations that were coherent groups without reference to age of exposure or to biological sex. And now these questions are wide open. I'm not saying they're settled, especially because nobody has asked or answered with a good research budget and a nice research lab, and hopefully grad students and postdocs, anything about causation. I have a hypothesis. There's some findings that there was a disproportionate amount of breast cancer amongst the A-bomb survivor females. That supports Rosalie Bertell's hypothesis because breast tissue is reproductive tissue. Interestingly enough, that's when the gender factor, as opposed to the sex factor, kicks in, and the big institutions are saying, yeah, see, it's just breast cancer. Big deal. Uh-huh. What? But, about half the people who were impacted by those A-bombs had breasts. Yes, whether they were little girls or big girls. Get over your fine selves. We come with them, and if they're more impacted by radiation, that shouldn't be dismissed. But for some reason, there's this idea that a female-specific cancer then lets everybody off the hook. Oh, it's just breast cancer.
Right.
That's the gender part. So,
right. Well, let's just say controversial is not the right word. You are in dangerous isn't the right word. What's the word I'm looking for, Mary? You're in a place.
Do a real pop culture answer, if you don't mind. I'm
Yeah,
in the intersection of Oppenheimer and Barbie.
Yeah.
Two big films of the year. I mean, if you put them really together instead of just their names, you get the hegemony of the nuclear world that created those bombs and dropped them on people, and you get the patriarchy of I'm just Ken.
That is interesting, right? There is no word. There's a word that needs to be invented. Oppenheimer and Barbie merger of those two words. But the point I was driving at is you've got interests, economic, political, industrial interest in moving forward with, nuclear energy, to say the least.
Oh yeah, it is. Let's just stop for a second. It is
Hmm.
a panacea. Nuclear energy is. It was atoms for peace. We're going to overcome the evil of weaponization of fission by turning it into the thing that's going to pull everybody out of poverty. Too cheap to meter. Going to solve this. Going to solve that. They even want to have a nuclear energy cure for cancer. Right? Causes cancer, cures cancer. Okay, we're seeing that, and now climate. Hey, oh my God, it's going to solve the climate crisis. It's the panacea approach to saving the world. But so far, it hasn't really accomplished anything but a lot of pollution, a lot of radiation exposure, and they've externalized the cost of the waste so that only Finland has discovered that the cost of dealing with the waste in a truly engineered, isolated manner exceeds all the, not just the money from the nuclear energy that created it, but all the profit from it. I mean, it's like it's a black hole and the rest of the world hasn't caught up with that piece of information. And when it does, it's going to shake its head about why didn't it put all that money into energy efficiency, into more solar, more wind, more storage, more all the things that are actually cost and time effective for reducing our footprint and sustaining more balance on our planet. So I can't let that go by without
No,
hitting it.
of course. And that's what I mean. I think we're at like an interesting time where, I think about, energy sources of 100, 200 years ago, wood burning stoves and coal burning stoves. I mean, those came with their own exposure, you might say. And so yeah, here we are. The nuclear is the panacea, but there are all these effects. I mean, maybe there's two questions here. Is like, number one is, given that what you are uncovering is, I mean, it's not to say that it's in opposition of a nuclear energy future per se, but it is not, sweeping the mutations under the rug, so to speak. And so, I mean, is there a
I've
future
lost
where
you.
nuclear energy is safe? I'm asking naively, and maybe let's leave that one for later. I think the question is right now, how does someone such as yourself do independent research? Because I suspect it's difficult to get grants to do this kind of studying, or I could be wrong. I'm just thinking back to my own, PhD days, that any kind of academic grants were, heavily subsidized by government, and government's grants were heavily influenced by policies, what we want you to discover. And I actually remember one of my supervisors writing an open letter to, I think it was the Global Mail at the time, it's a Canadian newspaper, talking about the need and the importance of basic research, right? Let me do a little riff on basic research, just to go back to like what your father was, charged with in terms of, I think it was like the microbiology of ionized water, let's say, or water exposed to ionizing radiation. Kerry Muller, who I know, discovered PCR. How did he discover PCR? Well, he took some LSD and he went for a surf, and he imagined, there's probably microbes that live at super high temperature environments. And so they have proteins that are probably heat stable, and DNA's conformation as a double-stranded molecule can be denatured if I heat it up. I just need replication proteins to stay stable so that when they reanneal, I can double the quantity and concentration of DNA every cycle. And by the way, that's how we were able to do all these COVID tests, or that's how we were able to discover things like cancer. That's how we were able to sequence the human genome. Basic research. Now, so that's one thing. I mean, I'm like a big proponent of basic research. It feels like it's a luxury to do, but then there's also like, well, what's the importance of counterculture research, right? I'll give you one more example relevant to the, my near dear to my heart, the genomic space, where the ENCODE project, which was a publicly funded initiative. I don't know to the tune of how much, but it was significant. But basically, it was to the best that I understood it to be true, is it's basically funded to deliver an a priori conclusion, which is, well, there's all these genes that are expressed, and there are these non-coding genes, and they're expressed, so we're going to prove the function of all this non-coding DNA, right? And my supervisor for Doolittle at the time wrote a paper around, hey, here's a simple question: what do you mean by function, right? So anyway, I'm kind of getting at the root of the scientific pursuit, the pursuit of truth, and maybe that's like the higher ordeal that you and I are talking around. I think that's a conversation we keep coming back to. But given that the truth that you're uncovering is inconvenient, how have you been able to navigate that? And how do you plan to continue navigating it?
Those are great questions. And I have to admit that I missed a little bit of it with this disruption of the electrons. So basic research. I actually call myself more of an analyst because I didn't go out and collect any data. I looked at data other people had done. So I've never had the capacity, nor actually even the inclination, to be engaged at the level that you have been, which is fundamentally vital and important to our expanding our relationship with the world we have come into. It's absolutely what keeps the human world turning. It doesn't keep the earth turning, but it keeps our world turning. So I'm a fan of basic research, but my work has always depended on the great generosity of wealthy people. So you called it a luxury? Yeah. My service work has been possible because people who had disproportionate amounts of wealth were interested in supporting what I've been doing. And it continues to this day. But I'm also supporting, instigating, using my time and energy to support people who are in institutions now, academic settings, because we need to have a broad library of information about this. All kinds of findings, all kinds of questions, all kinds of published work. We need to have people who are getting their PhDs get their degree doing funded work on basic questions about radiation, which, 10, 15 years, well, no, it's more like 15, 20 years ago, it was considered settled science. This new information unsettles that science, and it has to be re-engaged. And a younger generation needs to do it, and they need to do it in institutions of excellence, not in civil society, non-government organizations like I've been in. So I'm an instigator. I'm speaking to those people. I'm talking to people in the funding end of the federal government, where there are more and more women who are interested in having these kinds of questions asked and answered. But I'm not trying to get that funding for myself. I'm trying to get it for people who are in institutions who, when they publish, will go into the mainstream scientific media and, literature, and will begin to form the basis for what I hope will become better protection centered on those who are most affected. And if in terms of cancer, you choose the young girl to center your regulations on, because currently our regulations are centered on the adult male. And that makes sense. The whole Cold War was conducted with adult males on the front line of radiation exposure. But when they started putting nuclear reactors and nuclear factories of various kinds close to population centers, and those workers were going home, and as females joined the workforce, they didn't stop, look, or listen when they continued to use what is known as reference man as the yardstick for radiation harm. And so, as we build literature, hopefully we're going to get a better idea of where we should center that yardstick. And if we center it on girls, adult males will be protected 7 to 10 times more. So this is not an anti-male moment. It's a very pro-male moment. It's a give reference man his gold watch, his retirement party, thank him for his service, and step aside so we can have a reference individual who actually protects everyone. Because right now, little girls are not protected by reference man on a full order of 7 to 10 times.
Yeah. It's interesting. I hear you say that, and I think back to my professorial days. What among like the evolutionary biologies and biochemistry courses that I taught was the intro nutrition, micronutrients, macronutrient stuff. And you look at like all those RDAs, right? And a lot of those RDAs are the byproduct of, males going overseas and being subject to eating, non-perishable foods devoid of micronutrients. And so getting things like scurvy and rickets, beriberi. And so, the public health RDAs are extracted from that. But I really like how you framed it. It's like, okay, well, great. That was, a sacrifice that taught us many things. Actually, you know what? The other thing we were talking about at the top of this call, again, that search for a universal metric to define human intelligence, i.e. IQ. World War II was a big impetus in measuring recruits into the U.S. military, and that had all kinds of negative repercussions in terms of standardized testing, in terms of, basically dashing the dreams of anybody that didn't make their 11s exams, for example, because we've got these standardized tests. So, I don't want to tear down the scientific endeavor, because I think, there's, I'd like to say that we're aiming at the highest in terms of uncovering the truth, let's say, and that it's called research because we research. But I mean, there are certainly biases that creep in, and not least among them is the funding biases. And and again, the scientific pursuit is imperfect. The reason I bring up that intelligence example is because I kind of see, and it's really too soon for me to fully
Cutting
say
out
because I
on
haven't
me.
done the
I
full
don't know what you're
analysis, but I
saying.
looked at some of the research coming out of the All of Us project, right, which is sequence 1 million, let's say, biologically diverse humans in the U.S., combine this with their health data, really, really exciting. But then one of the prominent figures of the study was one showing the principal component analysis of DNA versus race. It's like race is not a trait. Like race isn't a trait like the way skin color is a trait, the way that height, like you can have complex traits that are biological, but then to cluster it based on race, I was like, oh, like what we're kind of not learning, because this was mistakes literally 100 years ago. And it's like we've got sharper tools, but it seems that, I don't know, maybe we're missing a call for interdisciplinary. Now, the good news is there was, call it, public outcry as to, hey, like that figure doesn't make sense, or it's insensitive, or the consequence of putting a figure together like that is to say that, you are predestined to be what you are. And now I can see that in a color, or I can see that in a in a stereotype. So anyway, all of that's to say, the scientific method is sound, but I think we forget that humans are driving it, and they're influenced by their cultural bias, and in some instances the economics bias, let's say. Okay, atomic eggs. Were we going to talk about atomic eggs?
We can talk about atomic eggs, but I did a bad thing when I introduced the pop culture piece, because I jumped right over the global piece of hope that we have. And I think I want to talk about the treaty if we're limited on time.
No, let's do the treaty, and yeah, look, we've been going for, yeah, we have time. Let's go to the treaty, and if we have time, maybe what we do is finish on the atomic eggs, and I think we've already agreed that we will have multiple conversations on this.
Yeah, and I'm not limited on time. I could easily go till 3 my time, but whatever makes sense. But
Right.
in terms of, we have to sort of stand for a moment as who we are and look and listen. And I've shared that my goal of really doing anything is about service. Service for what? Is it for truth and for knowledge? Those are fine. I'm not putting them down. But in my case, as a very young child, like 1967, I was 9 years old. I understood that my species had pushed its own home, its own planet out of balance, and that we were pretty much up a creek without a paddle. And that was 1967. And I was, as I said, less than 10 years old. And I got in a deep depression, couldn't get out of bed. And then the interesting thing is I got bored in bed. I was
Mm.
homeschooled and my mother had mental health problems. And so staying in bed was actually an option in the 4th grade for me. And, but I got bored. And so I constructed a hypothesis, and that was, okay, maybe I was right and the world was already ending at some point due to what we'd already done, but maybe not. And if not, we have the opportunity and to some degree the moral obligation to try. We don't know whether our effort is going to yield the results needed, but it's possible that it still could. And if that's the case, then we have to try. So I got out of bed. And as I say, I've been approaching my work from the perspective of service, from trying to prevent bad things from happening and to try and help turn around the things that were already happening that were bad. And clearly nuclear was one of the ones that was already happening that was bad. But I couldn't imagine working on nuclear weapons as my work, because for me, the issue there had more to do with the finger that would press a button that would launch the nuclear arsenal of my nation. And that finger was tied to a heart and a mind that was almost certainly male and incomprehensible to me. And I had absolutely no hope whatsoever that I could solve that problem, that human problem of somebody who would actually do that. I had to turn away from nuclear weapons, not my thing. So that's how I ended up, especially after my radiation accident, which then brought a nuclear waste issue to me. That's how I ended up working on nuclear waste policy for many, many years. So this part about disproportionate impact of radiation, also coming out of nuclear energy, was a shock when I received a call from a global ambassador from Austria asking me to come to a big, huge conference on nuclear weapons to talk about the disproportionate impact of radiation there in 2014 in Vienna, where there were over 1,000 people. Each nation state had an ambassador, their staff, my colleagues, the media, a bunch of independent science people, a bunch of observers. And we were all in the Hofburg Palace. And interestingly enough, after a ceremonial opening, I was the first speaker. And part of why I was the first speaker, I think, I'm second guessing the mind of the diplomats who put together the program, was because I, as a woman, as a US citizen, was going to stand there and apologize for Hiroshima and Nagasaki, and then also tell the world that radiation hurts girls more than any other part of the post-birth span. We can't really talk about the reproductive phase because we don't have enough data. It wasn't in the A-bomb survivors data set. So I was talking about people who were born, and of them, little girls are the most impacted. So those two things together, super, super boat rocking occurred. You said it's dangerous waters. On the first question and answer period, after two others, me first, then two other speakers, then coffee, then Q&A. And in the Q&A, the first hand up was the U.S. delegation. And what occurred was quite amazing. For 20 minutes, the U.S. Person who was speaking, it wasn't the ambassador, it was somebody below the ambassador, yelled, absolutely yelled, and went on and on and on and on for literally 20 minutes. We timed it. And I think that the global diplomatic community had all it needed to get to understand that the United States was not going to lead the world towards nuclear disarmament. This conference was dedicated to what happens to the humanitarian response in the wake of the use of a nuclear weapon or weapons. It was led by the International Committee of the Red Cross. It was led by non-nuclear nations. They put together the whole program to demonstrate that our world really cannot tolerate, let alone survive well into thriving, a major nuclear exchange. And so I spoke, I shared my information, and I triggered my country to display itself for what it is. And I'm not saying I hate my country. I love my country. I apologized for my country because I love my country, and it hasn't managed to do that for Japan or the survivors of Hiroshima and Nagasaki. I did so as a proud citizen. And I sat there and withstood the 20 minutes of yelling. And I laughed because I had to then answer, right? And that was some of the most uncomfortable moments of my life, to be up on that podium responding to this maelstrom of ire from representatives of my great nation. So then, having done that, the conference resulted in a humanitarian pledge. Right. And the humanitarian pledge was supported by 160 some nations. And that 2 years later became a vote in the General Assembly of the United Nations on the question of whether to write a new treaty governing nuclear weapons under humanitarian law. And that is the key here, under humanitarian law, because almost all, if not all, the other nuclear accords are written under military code and administered by the other body, which is the Security Council. And the Security Council, founded at the same time in 1945 in the wake of Hiroshima and Nagasaki, co-founded in the same meeting with the General Assembly of the United Nations. They're not the same body. They're part of the same umbrella, but they're separate. So the General Assembly, every nation who's part of the UN has one seat, one vote, simple majority rules, no vetoes. Over in the Security Council, all the nuclear nations have vetoes. So this is taking nuclear weapons for the very first time out of the Security Council. The other accords are still in force, and bringing it under General Assembly. And so they wrote the Treaty on the Prohibition of Nuclear Weapons in 2017. It passed the vote of the General Assembly and became open for nations to sign and then ratify. And in 2021, 50 nations had ratified the Treaty on the Prohibition of Nuclear Weapons, and it came into force. So now we're in the normalization phase in which nations come to understand that nobody's going to march into anybody else's nation and take away nuclear weapons. No, it is a legal framework that's enforceable with accountability for any nation to declare its lands and waters to be nuclear free. They had to give up on air. Nuclear weapons free. This is not jurisdiction over energy. And a framework and process for any nuclear nation to disarm under international law with protections, so that it's no longer a fantasy that somebody with their finger poised for the button feels that there's no option. Now there's an option. The option is we don't need them, we don't want them, we're going to get rid of them. Just like chemical, just like biological, we can grow past the nuclear weapons era, and we can do it together. And the reason my paper opened the door for this is because the model of humanitarian law is to show that a weapon has impacts on children disproportionately, on women disproportionately, on elders, and through time. And so the fact that it took 60 years for the cancers to all be counted and for the effects that are disproportionate on children and on female children and on women, because women are disproportionately affected compared to adult females compared to adult males, formed the basis for them to confidently walk from the Security Council over to the General Assembly. So thousands of people contributed to this whole process. So much other work was vital to bringing the nations to that room in 2014. But I have it from the guy who did the work that from 2014 to 2016, I'll share with you basically it's like a little comic book. There's these pictures with silhouette figures, and you don't have to know English. You don't have to know math. You don't have to know biology. You don't have to know genetics. You can just look at the pictures and go, oh. And people did that. And then they voted, and they all voted for a world that doesn't have nuclear weapons in its future. And I can die happy, honestly. I want to do more. I am doing more. There's a lot more to do, but having had a role in that process, I got turned into a dog and pony show, and I went many places besides Vienna and gave the same talk over and over again. And it was such an honor, such an honor.
Do you remember Carl Sagan? Do you remember Carl Sagan?
Carl Sagan saved my life. He taught me how to make a hypothesis. If Carl Sagan hadn't taught me how to make a hypothesis, my dad might have been able to, but Carl was Carl.
Did you actually meet him in person then?
Much later, after my radiation accident, and I was so afraid to say anything to him that I passed him a little tiny note.
Wow.
This is when I was in my 20s, and he came to speak at Yale.
Wow. Yeah. Well, because if you remember, so he wrote the book Cosmos. He's done many things, not to reduce it to that, but I remember that Cosmos was turned into a series. I think this was in the 80s, I want to say. Yeah.
Watched it religiously.
Yeah, right. And at the time it was like really here's, well, it's the cosmos, like everything ever in the cosmos in terms of how it works. But there were the undertones of this is where we could go, as an intelligent species if we don't blow ourselves up, right? So there was a fair amount of the conversation reserved to talking about the risks of nuclear weapons.
So that it was his lab that uncovered the whole phenomenon of nuclear winter. There's many other authors that also contributed, and there's now been work by my colleagues at Physicians for Social Responsibility and International Physicians for the Prevention of Nuclear War on the famine aspects of even a limited exchange. But Sagan was part of the first Voyager probes, or was it
Right.
Mariner? Anyway, the first one that went to Mars.
Mars,
And they get to Mars, and they've spent, a boatload of money, and they get to Mars, and the whole planet is enveloped in a dust storm, and they can't see anything. It's not a lander. It's going to orbit Mars and record information. So day after day, week after week, and they're so afraid that their funding is going to get pulled because they can't see anything. And finally, I don't know the name. Forgive me for telling a story that doesn't have that level of detail, but one of his graduate students was looking at it and suddenly looked up and said, well, this is what a planet would look like after a full-scale nuclear war because of all the particulate. And so they started running numbers and came up with the fact that if you even used 100 nuclear weapons, and then they got it down, I think, to even a smaller number on major cities that have a lot of concrete, so that all that particulate would be lifted up into the atmosphere, and it forms a shroud which can be thick enough to block the sun to a degree where not only crops don't grow, but green plants worldwide go into dormancy for at least a year or two. Maybe they aren't killed forever, but you stop having anything for a four-legged animal or a two-legged animal to eat. And so you start having major, major breakdowns, not only of our now electronic systems. Hello, we're not going to have an internet as much as it was invented to withstand a nuclear war. It's now tied up with all the electrical systems and telephone systems and everything like that are terribly vulnerable to these sorts of violent incursions. So anyway, Carl Sagan was able to transmit this information to his uppers in the US federal government, and they managed to retain the funding for the program because they posited nuclear winter. And there's a paper where the authors arranged their names in order to be TAPS, TAPS, for the military song that they play when things have gone bad. And S in the TAPS is Sagan. So that's the first paper on nuclear winter.
Wow. So where I was going with that question is, well, do you think Carl Sagan would be proud of your efforts? Not that that was the reason for doing it, but are we making progress, I guess? And if the answer is yes, how do we keep making progress?
I think that the Treaty on the Prohibition of Nuclear Weapons is progress. And I think one of the most disheartening things for me is that my nation, and I dare to say your nation, Canada, has pretty much blacked out any information whatsoever that this treaty exists, or that right now I think it's 62 nations have ratified, close to 100 have signed. So it's moving forward quite rapidly compared to some other treaties, like the other big treaty is the Treaty on Nuclear Non-Proliferation, or NPT, which also was progress when it was signed. But the nuclear nations promised to disarm, and that was in 1970. So 40 years of promises led the rest of the world to say, well, maybe we need a different approach. Maybe it's not about stopping the spread of nuclear weapons. Maybe it's about people standing up and saying it's not going to spread here. So more like the vaccine for a big outbreak. We can think of the TPNW's approach as as stop the spread by people having stood up and said, no, we're not going to do it. I think it's progress. I think now the job of thinking and loving people is to educate each other more about the Treaty on the Prohibition of Nuclear Weapons and other opportunities to reduce, especially undisclosed and involuntary radiation exposures, which means things like nuclear power plants. They can't operate without emitting radioactivity into air, water, and creating waste that there is no place to put that will contain it, at least in my country. And there's been a big process in Canada, but it's also not yet resolved in any way. So lots and lots of radioactivity that we have no idea how to keep it from exposing people. And I hope someday the Treaty on the Prohibition of Nuclear Weapons will include more aspects of nuclear activities. Certainly, there is value in the use of radiation. I am not anti-radiation. We have learned so much from the imaging and from various activities. DNA as a field wouldn't have been possible without some of the tracers that are used. So, I'm not anti-radiation. I'm anti-undisclosed and unnecessary and unbeneficial exposures.
Got it.
But how do you keep it going? I got to have a sip of water. That's one thing.
Yeah.
So last year, I took a year to be a fairy godmother. And I decided with my elder status that instead of working on my own project, I would find other people who were doing projects that were similar or advancing pieces of what I've defined as the mission of Gender and Radiation Impact Project, which is my organization. And I found the story of Setsuko Thurlow, who is one of the survivors of Hiroshima, who pushed so hard throughout her whole adult life. She's still with us in her 90s. For the Treaty on the Prohibition of Nuclear Weapons. She didn't know that that's what it would be called, but she knew that she wanted to work towards a world that was nuclear weapons free. And two women who did not know her, but one was the daughter of another survivor, made a film about Setsuko's life all the way up through to the Nobel Prize in 2017. And it's a beautiful way to tell the story of the treaty, as well as to elevate a woman who gave her life to service for this purpose. And so once I decided to work on it, I can't tell you how magical it is sometimes. If you just hold a question, you don't need to know the answer yet. You just hold the question and it's like it becomes a quest, right? Question, quest. And the quest on this one turned into its own thing. Of the woman who had made the film showed it at a major nuclear disarmament conference. And a woman who was at PBS, the public broadcasting system in the US, was there and called her up and said, we want the film. And so this film called The Vow from Hiroshima is going to start airing on US public TV in May of this year. And it'll be up for 3 years. I cannot imagine a bigger or wider way to do what I just said about educating and breaking this silence on the treaty. So you just sometimes have to follow your nose, follow your gut, follow your heart, let a question not have an answer, sometimes for a very long period of time, remain with it, sit with it, and eventually things begin to change around it. And so I think progress becomes almost slip slide easy when it's the right track. Like I went to work to stop the deregulation of radioactive waste, and people had already done a lot of work. So it wasn't me lifting all the way to the US Congress revoking that policy. No, but I got there in time to help be the relief energy. And we pushed it through, and tremendous number of victories followed on that because we were known as the people who got the federal government to do the right thing. And we did it over and over and over again for the next 20 years on radioactive waste. I'm very unhappy where it is today, but I am very proud of stepwise progress that was made on that. And now with the treaty, I'm not in the diplomatic corps. I'm not in the NGO community that works on UN stuff. but I am somewhere in between. And that space in between is where I get to see what I think needs to be done or hear what others convince me should be done. And now with this stature that I somehow have acquired, show up and where possible, instigate. So as I said, there are women who are in the funding community in the federal government. Well, they listen to me because of that stature I've acquired, right? And so that's good because I'm beginning to develop a list of people who deserve and will be moving forward questions that can help with making better protection for people. And I guess that's the final point I really want to make today is that we have lost the insight that our species, our human beings, are a life cycle. And it's almost like a figure eight because it's not a single cycle. We were introduced, if we were at all introduced, to the idea of a cycle. But this has got the female lobe and the male lobe, but they cross over at the point of conception where a new embryo is formed and the genetic material goes forward into the next soma, the child. And it may be male, it may be female, but if you don't have the whole thing, over time, you don't have any of it.
Right.
And it depends on the weakest part.
Mm-hmm.
So if we only talk about populations, we've lost the fact that there's a life cycle in which females exposed as children to radiation are now adult women, but they have like a 7 times higher probability of getting cancer than the adult female who wasn't exposed as a child. So the whole idea of a uniform population doesn't exist, right?
Mm-hmm.
And the whole idea of a uniform exposure of radiation. Well, what if that same amount of radiation, that X-ray, does one thing to the adult male and another thing to the boy? And a third thing to the girl. I mean, we have to go back to fundamentals here. And that's why I'm super excited to talk to you, Jeremy, because over time, as the DNA findings get integrated into these disease and health questions at the individual level, I think it's going to start making a whole lot more sense than having a unit that just is meaningless now.
Yeah.
You know, the RAM, the milliram, the sievert, the millisievert, they're all meaningless. I mean, it's a mess.
Mm-hmm. Yeah, you're absolutely right. Like exciting times with, the DNA side of things where it's now we can get the whole picture in terms of whole genome sequencing. And maybe that's where our part 2 can maybe pick things up is on this notion of atomic eggs and maybe some of the work that we're doing with the atomic veterans to do a bit of a deeper dive on that as its whole episode. But
I think those would fit together well. I think they would.
I think that I could. Okay, so we'll work on that. But in the meantime, Mary, I just want to thank you for sharing. I'm certain that folks listening will be interested in connecting with you. What's the best way for folks to connect with you, to find you?
Well, I'm wide open. And so start with the website, genderandradiation.org. And is a word spelled AND. So genderandradiation.org. My email is my last name, Olson, with a dot, and then my first name, Mary, at gmail.com, olson.mary@gmail.com. Call me up in the United States, 828-242-5621. You'll get me direct or my voicemail.
Wonderful. Well, thank you, Mary, for everything that you do. I've learned a ton, and I'm very much looking forward to our future conversation.
I am too, Jeremy. Thank you.
Thank you for joining us on this enlightening episode of the DNA of Things. Today, we had the privilege of hearing Mary Olson's inspiring journey from her early influences in biology to her groundbreaking work on the disproportionate impacts of radiation. Mary's dedication to uncovering the truth and advocating for better public health policies is truly remarkable. We've learned about the critical differences in how radiation affects women and children, the significant policy changes inspired by Mary's work, and the hopeful future shaped by global initiatives like the Treaty on the Prohibition of Nuclear Weapons. These insights are not just informative, but transformative, offering us a new perspective on public health and safety. We hope this episode has provided you with valuable knowledge, could change your life, and inspire you to take action. If you found Mary's story compelling, please share this episode with others who might benefit from her insights. Stay tuned for more episodes where we continue to uncover the remarkable ways genetics and scientific research are shaping our world. Until next time, keep exploring, stay curious, and share the love. Thank you for listening.